Okay, so hello and welcome back. So before we begin the today's sessions, let's quickly recap what we learned in our previous uh, session. Okay, so we covered Azure Virtual Network, that is VNets, subnets, network security groups. Okay, which is Energy Application Security Group (ASG), Azure Firewall, Azure Basin, Private Endpoint, Hub and Scope Architecture, VPN Gateway, Express Route. Okay, so most importantly, we learned the applications need networking to communicate, but communications not alone is not enough. Okay, so applications also need the storage, data protections, backup, disaster recovery, scalability, or compliance. So this brings us to another major AZ-305 domain. Okay, designing the data storage solutions. So our today topic is designing Azure storage solutions. Okay, which include the scalability, redundancy, architecture for the cloud. Okay, so why the today topic matters? So imagine a company running a virtual machines, web applications, databases, containers, analytics platform. So all of them generates data. Okay, then the question arises: where should the data be stored? How should it be protected? How should it be replicated? How should it be backed up? And how should cost be optimized? Okay, so storage architecture directly impact the, let me write here, storage architecture directly impacts availability, then performance, then security, then compliance, then costs. Okay, so as Azure Architect or Cloud Architect, the storage decisions are among the most important decisions we make. Okay, so by the end of this session, you will able to understand the Azure storage architecture, design a storage account, select multiple storage services, understand the storage performance tiers, design scalable storage solutions, apply a storage redundancy strategy, and also we look for the prepare for the AZ-305 strategy questions, and we think like an Azure storage architect. Okay, so now let's start with the subtopic or topic called designing Azure storage account and storage architecture. Okay, so imagine a multinational insurance company applications generates customer documents, image, backup, applications log, reports, analytics data. Okay, so organizations needs durable storage, secure storage, cost effective storage, globally available storage, and Azure storage provide the foundation. So what is the Azure storage? Okay, so Azure storage is a massively scalable, high available and the secure cloud storage platform. Okay, it's offers several data services tailored to different applications needed. Okay, and it's include the blob storage, like massively scalable object stored for text and binary data. Azure files, fully managed files shared accessible via SMB or NFS, and then queued storage, messaging the storage for reliable workflow decoupling, and the table storage, NoSQL key value storage for the rapid development. Okay, if I simplify these, what is storage? Azure Storage. So Azure Storage is a Microsoft Cloud storage platform. It provides the high ability storage, durable storage, scalable storage, secure storage for virtually any workload. So think of an Azure Storage as enterprise data foundations for the Azure applications. Okay, so why do we need Azure Storage? So every workload generates data. Okay, for example, virtual machines need disks, applications need file and objects, container need persistent storage, analytics platforms need large scale data repositories, and without storage, applications directly cannot persist the data. Okay, and what the real world scenario? So, let's suppose a healthcare organization stores which has a medical image, patients documents, audit logs, and backup files. And what is their requirement? So requirement is high regulatory compliance, long term retentions, global availability. Architecture foundation will be Azure storage. Okay, so what is the Azure storage architecture? So flow, so it will look like, let me write here, Azure storage architecture flow look like applications, then it goes to storage. Okay, then it goes to combined of blob storage. Okay, or file storage. Okay, queue storage and table storage. Okay, so these are, okay, so if you see, so these are Azure storage architecture flow. Okay, so the storage account is a top left resource. So what is a storage account? So a storage account is a container of Azure storage services. It provides the security, replication, access control, billing, management. Okay, and think of it as a storage boundary inside the Azure. Okay, and what are the core storage services? So a storage account can host the blob storage, which store the object storage, Azure files, manage the file shares, queue storage, which is for messaging, table storage, no SQL key value data, and what are the architecture diagram flow of it? So it will be start from storage account, then it goes to your blob, same blob, files, queue, and table. Okay, so what are the blob storage overview? So one of the most important Azure storage services, blob storage store the unstructured data. Example, image, videos, documentations, backups, and log. Why blob storage? So traditional file systems struggle with the petabytes of the data. So blob storage is designed for the massive scales. Okay, and what are the blob storage architectures? So blob storage architecture flow look like, it starts from storage account, then it goes to container, then it goes to blob storage or blob objects. Okay, so these are the blob storage architecture flow. And what type of the blob storage? So blob, most common, used for documentations, image, video, backups. Append blob, optimized for the log files. Page blob, used by the Azure managed disks. Okay, now what is the Azure file overview? Okay, so Azure files provide the managed SMB file shares, example, shared company drives in Azure. So why Azure files? So many applications require shared file access. So traditional files server replacement. So what are the Azure file architecture? So Azure file architecture flow look like? It start from Azure file, okay, then it goes to SMB share, then it goes to multiple clients, okay. So these are storage Azure file architecture flow, okay. So in real world example, financial team, HR team, operations team, so all access the same file. And what are the queue storage overview? So it provides a simple messaging quick, okay, to use for the processing, application decoupling or workflow, okay. For example, it starts from application A, then it's queued and then goes to application B. And what are the table storage work overflow? So it provides the NoSQL key value storage used for the large scale metadata, lightweight applications, simple structured data, okay. And the storage account types. So in our AZ-305 topic, there is general purpose V2, GP V2 most common, support the blob, file, queue, table recommended for the most of the workload. Okay. And other is premium, which is optimized for high performance, low latency, used for specialized workload. So what is standard GPv2? So the recommended standard for the most workload GPv2 account provide the access to all Azure storage service with the magnetic SSD backing. So it is cost effective per GB, support hot, cooled and archive tiers, and support all the redundancy models. Okay. And what are the premium? So premium is a high performance. It is designed for the IO incentive workload requiring the extremely low and consistency latency, backed strictly by the solid state drives, which is SSD. Okay. Can you please mute your hello?
Yeah, sorry. I'm listening. Sorry about that.
Oh, can you mute if like I have so much background noise from your side?
Yeah, go on. That's fine.
Okay, no issue. So what is premium? So it is specialized for the account blob storage file shares, no accessing tiering available, and high cost and supervisor IOPS. Okay. So enterprise design, what are the enterprise design considerations? So architecture should evaluate the performance, scalability, durability, compliance, and cost before selecting the storage architectures. Okay. So yeah, let me. So what are the common mistakes? So common mistakes using the premium storage unnecessarily. No life cycle management, no replication planning, excessive public access, no retention strategy, and poor naming standard. And what are the best practices? So use GPv2 by default, implement private connectivity, apply least privilege access, design retention policy, plan replications carefully, and monitor the storage continuously, and which is optimize cost regularly. Okay. And what are the
Ah,
AZ-305 exams perspective? So which is very common scenario, like if the store millions of the documents and image, so answer will be blob storage. If this
ah,
scenario will be provide the shared SMB access, so answer will be Azure Files. And if the scenario will be store application message, so answer will be queue storage. Okay. And if the scenario will provide or ask to need a storage account supporting all the Azure storage service, so answer will be general purpose V2 storage account. Okay.
okay. So
So
we've done something like this before. Premium and standard GPv2.
mhm.
We've done it before. The
Yeah,
general purpose, yeah.
yeah, we just in that we just go with the just teaser. Okay. And in this sessions we like go deeper. Okay. So
Okay, okay,
so
okay.
that was a
Because that
very,
one was
yeah, that was very introductive part. Okay.
okay,
I
okay,
just
okay.
saw you the overview of everything, like how the
Okay.
systems goes and what topics we have to cover. Okay. And now we are continuing to the each topic in the detail. Okay. So now our next subtopic will be designing the Azure Blob Storage access tier lifecycle management and data optimization strategy. Okay. So in our previous subtopic, we learned Azure Storage Account, Blob Storage, Azure Files, Queue Storage, Table Storage, okay, and Storage Architecture Fundamental. Now we focus on the most important Azure Storage Service for AZ-305, okay, Azure Blob Storage. So in real world, Azure environment blob storage is often responsible for the storing the application data, image, video, log, backup, data lake content, and archive data. So understanding the blob storage design is critical for the both AZ-305 exam and your enterprise architecture project or any interview. Okay. So imagine a global insurance company, data generated daily of policy documents, claim images, medical reports, audit logs, and backup files. So data volume is 50 TB today, 100 TB next year, and 500 TB within 3 years. So what are the requirements? So requirement will be high durability, low cost, global scale, long-term retentions. And Azure Blob Storage is designed especially for these scenarios. So what is the Azure Blob Storage? So Blob Storage is a Azure object storage service used to store unstructured data. Okay, and why do we need the blob storage? So its traditional file server struggle with the millions of the files, metadata of the data, and global access. And blob storage provide the massive scale, high availability, durability, and cost effective. Okay, so okay, now what are the access tier? So one of the most important AZ-305 exam topic is your blob storage provide the hot tier, cold tier, archive tier. Choosing the correct tier significantly impact the cost. So what is the hot tier? So hot tier designed for the frequently access data. Okay, and example, web applications files, current documentations, active reports. And what are the characteristics? So highest storage cost, lowest access cost, and fastest access. Okay. And what are the cool tier? So it designed for infrequent access data. Example, monthly reports, older documents, backup copies. Okay. And what are the characteristics? So lower storage cost, higher retrieval cost, and good balance. Okay. And what are the archive tier? So it designed for the rarely access data. Example, compliance records, historical backup, long-term archive. And what are the characteristics of it? So the lowest storage cost, highest retrieval cost, and retrieval delay possible. Okay. So if I compare the tier, so if the feature is storage cost, so it is high in the hot, medium in the cold, and low in the archive. Okay. And if the feature is access cost, so it is low in hot, higher in cool, and highest in archive. And if the feature is availability, so it is in immediate in hot, immediate in cool, and rehydration required in archive. And if the feature is use cases, so active data is in the hot, occasional access in cool, and long term retention in the archive. Okay, so let's take some easy 305 exam tip. Some common questions are data accessed daily, so answer will be hot tier. Data access monthly, so answer will be cool tier. Compliance data retention for 7 years, so answer will be archive tier. Okay, so they so now the data lifecycle management. So one of the most important cost optimization strategy. What are the problems? So organization often store the 100 TB of the active data even when the 80 TB rarely access. So cost become excessive. So what is solution? So solution is life cycle management policy. Automatically move the data between the tiers. For example, it starts from day 0, then goes to hot tier, then goes to 30 days, then goes to cool tier, then goes to 180 days, and then goes to archive tier.
Yeah.
Okay, let me write here.
Yeah, absolutely.
So day 0, it goes to
Cool. Too
hot
hot.
hot tier. Okay,
Yeah.
Then day 30 it goes to cool tier. Okay, then it goes to 180 days, it goes to archive tier. Okay, okay. So what are the life cycle management architecture? So it will be life cycle architecture flow look like blob data goes to life cycle rules, then it goes to automatic tier movement. Okay, so these are life cycle architecture flow for the life cycle management. Okay, now what are the blob versioning? So it provides the multiple version of the objective. Example, document version 1, document version 2, document version 3. Support recovery for the accidental change. And what is the soft delete? Protect the against the accidental deletions, which in which deleted object remain recoverable. Okay. And what are the blob immutability? So important for the compliance, which support the right once may read many. Okay, used by financial institutions, healthcare organizations, and government agencies. And what are the static website hosting? So blob storage can host the static website, for example HTML, CSS, and JavaScript without a web server. And a storage security, so it is critical architecture responsibility. Okay, and what are the encryptions at rest? So it's enable automatically protect the stored data, and encryptions in transition, so it's communicate the https. Okay, and it also has Microsoft intra authentications, which prefer the authentication model. Okay, and also share the access signature, which is SAS, provide the life time limited access, for example download files valid for 24 hours. Okay, and private endpoints, which enterprise best practices like architecture will be, it start from application, then private endpoint, then blob storage, which avoid the internet exposures. Okay, so now what are the common mistakes? So common mistakes: keeping all the data in hot tier, no life cycle policy, no versioning, no soft delete, excessive public access, and poor retention planning. Okay, and what are the best practices? So best practices: use hot tier for the active data, use cool tier for the infrequent access, use archive for the long term retention, implement the lifecycle policy, enable the soft delete, enable the versioning, use the private endpoints, and monitor the storage uses. So what are the
Okay.
exam AZ-305 exam perspective? So the common scenario will look like: if the storage active website content, then answer is hot tier. If the storage store monthly backup data, cold tier. Retention applic compliance record for 10 years at the lowest cost, then answer will be archive tier. And if they automatically move the older files to lower cost storage, then answer will be life cycle management policy. Okay, so these are your storage access tier and their characteristics. Okay, now we are moving to design Azure storage redundancy, LRS, ZRS, GRS, RAGRS, ZGRS, data protection, and disaster recovery architectures. Okay, so in our
Okay.
previous part, we
Okay.
learned the Azure Blob Storage access tier, lifecycle management, soft delete, versioning, immutable storage security. However, at
Yeah.
critical attack questions remains: what happens if the storage infrastructure fails? Okay,
Sales.
consider
Hmm.
disk failure, rack failure, data center failure, regional outage. Okay, so how do we protect the business data? So this is where the Azure storage redundancy becomes the one of the most important AZ-305 topic.
Presents. Hmm.
Okay,
Hmm.
so
Hmm.
imagine a healthcare organization storing the patient record, medical image, insurance document, or audit logs. So what are the business requirements?
Hmm.
No data losses, high availability, disaster recovery, regulatory compliance. The ITech must decide how many copies of the data should Azure maintain and where should
Hmm.
those copies be stored. So what is storage redundancy? Okay, so storage redundancy means multiple copy of the data are maintained automatically by Azure. The purpose is failure occurs, data remains available. Okay. Without redundancy, failures, data loss. Why do we need
Yeah.
redundancy? Failures happens. For example, disk failure,
Absolutely.
server failure, rack failure,
Failure. Hmm.
data center
Hmm.
failure, region disaster. So storage redundancy
Hmm.
protect against these risks. Okay. So Azure redundancy options, Azure provide the LRS, ZRS, GRS, RA, GRS, GR, GZRS or RAGZRS. Okay. So these are heavily tested in AG305. Okay. Now stand the decision framework. So architecture balance the cost, ability, durability, recovery
Yeah.
requirement and compliance. So higher resilience generally means the higher cost. Okay. So what the first, what is LRS, which is local redundant storage, the simplest redundancy model. Okay. What is it? So it is so Azure store the three copy of the data within the single data center. Okay. Like a data center which has three copy 1, copy 2, copy 3, and so on. What is benefit? Lowest cost, simple, high durability. Okay. And what are the limitations? Limitation: do not protect against the data center failure. Okay. Now what are the use case? So it is used in development, testing on non-critical data. Okay. And what are the zonal redundant storage, which is ZRS? So Azure store copy across the multiple availability zones within the same regions. So architectures look like a region has a multiple each copy of the each zone, like zone 1, zone 2, zone 3, and so on, of their copies. Okay. And what are the benefits? It survives data center failure, high availability, automatic replications. Okay. And what are the use case? So it is used in production applications, critical business data. Okay. And what are the LRS versus GRS? So if the feature is copies, so LRS has a 3 copy, GRS has a 3 copy. If the feature is data center failures, so there is no any protections against the LRS, but in the GRS there is protections. For availability zone protections features, no protections in LRS, but protection in ZRS. And what are the cost features? So the cost is lower in LRS and higher in ZRS. And what are the geo redundant storage, which is GRS? So Azure store the 3 copy in primary region plus 3 copy in secondary region. So it look like the primary region has 3 copy, and then it goes to replications, and then secondary region has also 3 copy. What are the benefit? Regional disaster protections, geography redundancy, and disaster recovery support. For example, East US replicated to the Central US. Okay. And what are the limitations? Secondary region not readable during the normal operations. And what are the use case? So enterprise production, disaster recovery workload. Now, what are the read access geo redundant storage, which is RAGRS? So same as GRS plus, read access to the secondary region, and its architecture for look like primary regions has read write, then it goes to secondary region, then it has read access. What are the benefit? DR protections, read access, reporting, analytics. And what are the example? So user can read from secondary region even when the primary region is healthy. Okay.
Okay.
And what are the GRS versus RAGRS? So if the feature is secondary replications, it is enabled for GRS and also enabled for RAGRS. And if the feature is read secondary region, then it is not enabled for GRS but it enabled for RAGRS. If the feature is DR protection, so it is enabled for GRS and also enabled for RAGRS. Okay. Now Geo Zone Redundant Storage, which is GZRS.
RS.
So one of the most resilience options. It combines the ZRS plus geo replications. Like a primary region has the zone 1, zone 2, zone 3, which replicates to secondary region. Benefit: zone failure protections, region failure protections, enterprise resilience. Okay. And what are the read access geo redundant geo zone redundant storage, which is RAGZRS. So it is the highest resilience options, provide the zone protection, regional protection, and secondary read access. So it architecture flow look like it start from primary region. Right here. Flow of RAGZRS. It start from primary regions. Then it goes to multiple zone. Then it goes to replication. Then it goes to secondary region. And finally, it read your access. Okay.
Uh-huh.
So, okay. Now, what is data protection features? So, beyond the applications, okay, what is soft delete? Protect against the accidental deletions. Blob versioning, protect against the accidental changes. A snapshot, point in time copies. And what is immutable policies? Warm storage, used for compliance. Okay. And what are the backup versus replications? So, which is very common in AZ-305 questioning. Replications protect against the infrastructure failure, and backup protect against the user mistake, corruption, or accidental deletions. Okay. So, architecture often need both. Okay. And what are the storage disaster recovery strategy? So, enterprise design typically include the replications, versioning, soft delete, backup, and recovery procedure. Okay. And what are the common mistakes? So using LRS for the mission critical data, confusing the backup with the replications, no DRA strategy, no versioning, okay, no retention planning, and no and overlapping for unnecessary redundancy. And what are the best practices? So align redundancy with the business requirement. Use ZRS for zone resilience. Use GRS for the regional DR. Use RAGRS when read access needed. Use GZRS for critical workloads. Enable versioning and soft delete and test recovery procedure. Okay. Now, what are the exam perspective for this? Okay. So, let's take scenario one. If protect against the data center failure, then answer is ZRS. If protect against regional disaster, then answer will be GRS. And read access required in secondary region, then answer will be RAGRS. And
Yes.
highest regions for the mission critical workload, then answer will be RAGR, sorry, GZRS. Okay.
Yes, yeah.
Okay. Now we have to move next topic, which is designing Azure managed disk Azure file storage security performance optimization and enterprise storage architect. Okay. So in our previous subtopic, we learned how the Azure storage protect data through what? LRS, GRS, GRS, RSGRS, GZRS, and
RS.
RAGZRS. Okay. And we also
ZRS.
learned the replication protect. Okay. And backup protect data. Now we move to another important AZ-305 objective, which is designing the storage performance and enterprise storage architectures. So as a cloud architect, we must answer which disk type should a VM use, when should Azure Files be used, how should storage be secured, how should performance be optimized, okay, how should enterprise storage environment be designed. Okay. So imagine a global insurance company. Application include the claim processing, customer portal, SQL database, file shares, backup systems. Okay. And different workload have different requirements like high IOPS, low latency, shared shared file access, secure storage, cost optimization. A single storage solutions cannot justify every requirement. Architect must select the
Okay.
correct storage architecture. Okay. So Azure Managed
Okay.
Disks, one of the most important Azure storage services. So what are the managed disks? So Azure Managed Disks are fully managed block storage for the Azure virtual machines, like in which Azure manage the availability, replication, storage infrastructure, lifecycle management. And why managed disks? Without managed disks, VM goes to a storage account, then goes to disk files, more operational complexity. With managed disks, VM goes to directly to the managed disks. Azure manage the backend storage. Okay.
Okay.
So what are the types of the managed disks, which is extremely important for our AZ-305 topic? So standard HDD, which is lowest cost option, best for development, testing, and backup workload. What are the characteristics of it? It is the lowest cost, lower performance, and non-critical workload. Then
Okay.
another is a standard SSD, balanced option, best for web server, application server, general workload. What are the characteristics of the SSD? So it has a better performance, moderate cost, and products are suitable. Now the third one is premium SSD, which is high performance options, and it is best for production database, enterprise applications. And what is the characteristics of the premium SSD? So it has a low latency, high IOPS, and enterprise performance. Then we have another fourth one is premium SSD version 2, which is modern premium storage offering. It's provide the higher flexibility, better performance control, and low optimizations. Okay. And then ultra disk, which is highest performance option, best for SAP HANA and high-end databases and mission critical system. What are the characteristics of the ultra disk? So extremely high IOPS, extremely low latency, and highest cost. Okay. So now if the question asks, let's take some examples. If requirement is mission critical database requiring extremely high IOPS, answer will be always ultra disk. If requirement is production web applications, answer will be premium SSD or standard SSD depending upon the performance requirement. Okay. So yeah, the other topic is Azure file sync, which is important for hybrid scenario. Okay. And what are the benefits? So hybrid file services, cloud trading, centralized management, and reduce storage cost. Okay. Now what are the storage security architecture? So one of the most important architecture responsibility, there is a layer for security, identity, network, encryptions, monitoring. Let me write here. Storage security architectures layers.
Fantastic.
It has identity, then network, then encryption, then monitoring. Okay, these are storage security architectures layer. Okay, what is
Okay.
encryption at rest? So it's enabled by default, protect the storage data. Encryption in transit, HTTPS, SMB encryptions, TLS. Microsoft intra authentications preferably identify the model's benefits. Centralized authentications, RBAC and conditional access. And what is shared access signature, which is SAS, provide the delegated access without exposing the account key. Okay, like for example, vendor access and vendor access are valid 24 hours. Storage account key support but less preferred. Architects should minimize their uses. Private endpoints, enterprise best practices. Architect flow look like it start from application, then goes to private endpoint, then go to storage accounts, which eliminate the internet exposure. And what are the storage firewall? Storage accounts support the allowed network, denied network, trusted service, and IP restrictions. So what are the enterprise security architectures? So it starts from user, then intra ID, then private endpoint, then a storage account. Okay. So what is performance optimization? Is a very common tech responsibility. Performance factor evaluate the latency, throughput, IOPS, access pattern, object size. Okay. So choosing the correct storage, frequently access file used for the hot tier, rarely access data used for cool tier or archive tier, and high performance databases, premium SSD and ultra disk. Okay. And what are the caching strategy? Performing can be improved through the Azure CDN, Azure Cache for radius, and local caching. Okay. So enterprise storage architecture look like as large organizations often implement it start from the application, then goes to network, private network, then goes to storage account, then goes to replication, then backup, then monitoring. Okay. Now, what are the common mistakes? Okay. So common mistakes are using the ultra disk uncertainty. Okay. Then no private endpoint, no storage firewall, excessive account key is uses, poor lifecycle management, and no monitoring. And what are the best practices for it? So use managed disks, use premium SSD for the production workload, use ultra disks only when justified, implement private endpoints, use intra authentications, enable monitoring, optimize storage tiers, and test recovery procedure. So also
Mm.
now let's take some AZ-305 exam perspectives questions. So if scenario will look like high performance database requires extremely low latency, then answer will be ultra-disk. If scenario will look like shared SMB storage required access multiple VMs, answer will be Azure Files. If scenario looks like
Yes.
hybrid file services required, so answer will be Azure File Sync. And if this storage account should not be publicly accessible, then answer will be private endpoint storage firewall.
Yeah.
Okay. So now today we complete another AZ-305 major domain, which is design, Azure storage, data protection,
Storage.
enterprise
Yeah.
storage, and architecture. So every Azure workload depend upon storage. Whether you are designing the virtual machine, AKS cluster, app
Okay.
services, databases, analytics platform, the success of the architecture depend on how the data is stored, protected, secure, and recovered. So as an Azure architect or cloud architect, storage decision directly affect the performance, availability, security, compliance, disaster recovery, cost optimizations. Okay, and we also looked for Azure storage account. Okay, we started with the Azure Storage Account. A storage account is a top level Azure storage resources. It provides security, replications, billing, access control, storage management. Okay, then we looked for Azure Blob Storage, one of the most important Azure storage services. Blob Storage is the object storage for unstructured data. Okay, we looked for the blob type. Blob most common used for document, image, videos. Append blob used for
Files.
log files. Page blob used for a managed file. Then we looked for blob storage access tier. Okay, one of the highest value AG-305 topics like hot tier, for example, frequently accessed data. Okay, cold tier for infrequently accessed data. Archive tier for rarely accessed data. Okay, so these are tier selection summary. Okay, like hot is best for the active data, cold is best for the
Okay.
occasional access, archive is best for the
Yeah.
long term retention. And fourth,
Yeah.
we looked at we saw the life cycle management, a major cost optimization scalability capability. Life cycle policy automatically move the data like from hot to cold to archive
Oh,
based on the age and access requirement. We also look for its benefit like cost reductions, automations, compliance strategy. And fifth, we looked for the data production failure. Okay, like soft
yeah.
delete, blob versioning, snapshots, immunity policy. And sixth, we looked at for the storage redundancy, one of the most important heavily tested AZ-305 topics. Like we we saw that there is a LRS, ZRS, GRS, RSGRS, GZRS,
Yeah.
RSGZRS.
Just said
Okay,
that.
yeah. Then we look soft uh, when now we also looked for the Azure managed disks. Okay, like a standard HDD, standard SSD, premium SSD, premium SSD version 2, and ultra disks. Okay, and we also look for the Azure files. We also look for the Azure file syncs. Okay, and we also look for this Azure storage security. Okay, like encryption at risk, encryption in transits. Okay, like Microsoft intra authentication and shared access
Yeah.
signature, that is SAS. Okay, and private
Yeah.
endpoints and storage firewalls. Okay, and we also reviewing some AG305 notes, for example, perspectives like storage account, blob storage, XSTS, lifecycle
Yeah.
management, soft delete, versioning, LRS, GRS, JGRS, RAGRS,
You said that
GZRS,
right.
managed disks, Azure file syncs, private endpoint, intra authentications. Okay, so I
Yes,
have
then
a
the layers.
question. Can you tell me, like, a financial institutions requires a regional DR and secondary read access? Okay, so which redundancy model is most appropriate? Can you tell me?
For who?
Suppose a financial institutions require a regional DR and secondary read access. So which redundancy model is appropriate?
Sorry, I didn't hear that. That was not clear enough.
A financial institutions requires regional DR and secondary read access. So question is, which redundancy model is most appropriate? So
Hold on.
answer will be
Hold on. Hold
regional
on. No, no.
redundancy
Don't
plus read access, that
read
is
that section. Don't tell me.
RAGRS. Okay,
Yes. RAGZ. RAGRS. Yes, not
yeah,
RAGZR.
exactly. Yeah, exactly. So
Yeah.
yeah, that's bring us to end of the this sessions. Today we learned how the Azure iTech design storage accounts, blob storage, Azure files, managed disks, storage redundancy, lifecycle management, storage security, enterprise storage architecture. So what is the key lesson for this session? Okay, so let me write here the chat. The key lesson from this session is data is one of the most valuable assets an organization owns.
Yeah.
Okay, storage architecture is not simply about storing the data, it is about protecting
In the data.
protecting securing, optimizing, and very important, recovering that data when failures occurs. Okay, let me repeat once again. So key lesson from this session is data is one of the most valuable assets an organizations owns. The storage architect is
Absolutely.
not simply about the storing the data, it is about the protecting, securing, optimizing,
Data,
and recovering the data when failure
data,
occurs.
yeah.
Okay, so before our next session, please review the blob storage, access tier
It
lifecycle
does.
policy, LRS versus ZRS, GRS, RA, GRS versus GRRS, manage disk, Azure file, and storage security. So these topic appears frequently in both your AZ-305 exam and Azure Solution Architect interview and projects. Okay, yeah. So thank you for
Hmm.
learning with me today. We will see you
Yeah,
in
thank
next session.
you.
Okay,
Yeah, I'm trying to note down
bye
this.
bye. Yeah.